So this is the next question. So if you observe this question, this is the question from the electromagnetic theory. In the ISRO examination, they are mostly concentrating on the electromagnetic waves, electromagnetic theory, radars and antennas and microwaves concepts. Okay, they are mostly asking from the gate questions only. Okay, suppose if you, from the gate syllabus only. So if you compare the previous papers and the gate examinations, so whatever the questions asked in the gate examination, and they are asking the same pattern in the ISRO examination also. So that's why you have to concentrate on the gate examination. So definitely you can answer the ISRO question paper. So that's why you have to, mainly in the EMT, they are copying the questions from the gate examination, and they are giving the questions in the ISRO. So that's why you have to focus on the gate. So definitely the ISRO exam will be easy for you. Okay. Now if you come to the question, here the question is the current density at the surface of a thick metal plate is 100 ampere per meter square. Okay. What is the skin depth if the current density at a depth of 0.0059 centimeters is 0.272 ampere per meter square. Here some values are given, logarithm of 10 and logarithm of 2.72 are given here, and we have to use these values in this. Okay. So if he is talking about the skin depth of a metal plate. Metal plate means it is a conductor, right? So it is just like, so already we know the skin depth concept in the electromagnetic waves. So what is the skin depth concept in the electromagnetic waves? What happens? The amplitude of the electromagnetic wave will be like this, E0 into e power minus alpha z. Okay, what is skin depth there? Here the skin depth is, it is the distance traveled by the wave, at which the amplitude decays to 1 by e times of its initial value. Okay, that means what is the skin depth there? There delta is represented with z, okay, is equals to 1 by alpha, right? Here delta is represented as 1 by alpha. It is the distance only. Okay, suppose if z is equals to 1 by alpha, that is called as the delta. Okay, so delta is equals to 1 by alpha, then the amplitude becomes E0 divided by E. So this is called as the skin depth. Similar to but here in this question, he has given the current density. Here also the current density also changes with the distance. Okay. So here also the current density, similar to this, the current density changes here. So whenever the current is going into the conductor, okay, from the conducting medium, from the top surface to the midway of the conductor, so the current density varies like this. So J can be written as J0 into e power minus alpha into Z, right? Already we know alpha is equals to what? 1 by delta. So I can write J0 into e power minus 1 divided by delta into Z. Okay, it is J. Okay, so what is meant by J? J means it is the initial value of the current density. Here what is E0? E0 is the initial value of the amplitude of the EM wave. Similarly, J0 represents the initial value of the current density. Right? Initial value of the current density is how much? It is given as 100 ampere per meter square. Why it is initial value? He said that the current density at the surface of on the surface it is the ampere per, it is the J0 is equals to 100 ampere per meter square. So as the wave is going into the conducting surface, so definitely its current density decays like this, exponentially decays, right? So now we know the skin depth here and here are same. So now what happens here? What we have to find? Then what is the skin depth if the current density at a depth of 0.0059 centimeter is 0.272 ampere per meter square. That means we have to find the distance Z if the skin depth is given. So what we have to find? We have to find the skin depth delta at this distance is the current density is this much. Okay. So at Z is equals to at z is equals to 0.0059 centimeter. So that means we can write this one as it is 59 micrometer, right? So at z is equals to 59 micrometer. Now what will be the current density? The current density is given by 0.272 ampere per meter square. That means if you put, observe this, if you put z is equals to 59 micrometer here, you will get 0.272 ampere per meter square. Now what will be the value of delta? We have to find the delta here. So from this it is 0.272 is equals to 100 into e power minus 1 divided by delta. It is how much? It is 59 micro means 10 power minus 6. So here I am writing e power minus, here 1 divided by delta. It is 59 into 10 power minus 6 is equals to 100 divided by 0.272. Okay, but here he has given some values here. Observe this. So if I write the logarithm value here, how much you will get? So here 1 divided by delta, 59 into 10 power minus 6 is equals to 1000 divided by 2.72. I am multiplying 10 and divide with 10. So here you will get, so this is how much? You have to write ln here, natural logarithm, right? Because you are removing e here, so you have to write logarithm and on both sides, so you will get ln of this one. So finally how much you will get? So here you will get, this is ln of 1000 minus ln of 2.72. So already it is there, it is 10 cube. So it is 3 into ln of 10 minus ln of 2.72. So this is 3 into ln of 10 is how much? 2.3. So it is 6.9 minus 1. So it is 5.9 is the answer for this. But it is what? How much? We have to find the delta. So delta we have to find. So delta is equals to 59 divided by 5.9. This is how much? 10 power minus 6. So this will be, what will be the final answer? So this will be, it is 10 micrometers. Answer is 10 micrometers. So this is the final answer. So if you know this, you can relate this concept to the current density also. This is the skin effect problem. Okay. So it is very easy for you. Right. So we have to find the skin depth. We have to find the skin depth. Okay. If the current density at a depth of 0.0059 centimeter is this one. Okay. If the current density is this one, at what distance? 59 micrometer. Okay. So this is called as the skin depth. Now come to the next question. Okay. If you come to the next question, an air-filled rectangular waveguide, air-filled is very important, and rectangular waveguide R1 is operating at a frequency of 2 GHz and another air-filled rectangular waveguide R2 is operating at 4 GHz. The waveguide, okay, it is operating at 4 GHz. Now, the waveguide lengths of these waveguides at their respective frequencies are equal. The guide wavelengths are equal, has given at their respective frequencies. Okay, full stop. If the cutoff frequency of R1 is 1 GHz, now what is the cutoff frequency of R2 in gigahertz? Okay, here the options given as, option A root 10, option B root 11, option C root 12, option D root 13. So these are the options given like this. Okay, it is also asked in 2017 ISRO examination, right? So there are two rectangular waveguides are there. Okay, one rectangular waveguide R1 and there is another rectangular waveguide R2. There are two rectangular waveguides are given. Now the first rectangular waveguide is operated at a frequency of 2 GHz. That means the operating frequency F1 is equals to 2 GHz, right? and another rectangular waveguide R2 is operating at how much? It is 4 gigahertz. It is given like this. Full stop. Now the guide wavelengths of this waveguides at their respective frequencies are equal. He has given that guided wavelength. What is meant by guided wavelength? It is represented with lambda g. It is represented with lambda g. Lambda g is equals to lambda divided by cos theta. Already we know. Okay? Lambda divided by cos theta. Already we know cos theta. What is cos theta? Cos theta is equals to how much? Root over 1 minus fc divided by f whole square. But we are talking about the first waveguide, right? Okay, so I am naming this one as lambda 1, fc1, f1 like this. So this is lambda g1, right? So what is lambda 1? Already we know. See, and one more thing is given. fc also given. If the cutoff frequency of the first waveguide R1 is how much? fc1 is given. fc1 is 1 gigahertz. Okay, 1 gigahertz. So in this we know what? F1 we know and fc1 we know, and what will be the lambda 1? So from this, what is lambda 1? The wavelength of this, the wavelength in this waveguide is, from this what is lambda 1? F1 is there, lambda 1 is equals to 3 into 10 power 8 divided by frequency is how much? 2 gigahertz, means 10 power 9, 2 into 10 power 9. So this will be is equals to, it is 1.5 into 10 power minus 1. That means it can be written as, it is 15 centimeters. It is 15 centimeters, right? So it is completed, right? And what will be the lambda 2 here? Here the lambda 2 is equals to, so from this lambda 2 is equals to, it is 3 into 10 power 8 meters per second divided by, now f is how much? 4 into 10 power 9. So this will be, it is 7.5 centimeters. Here the lambda 1, lambda 2 are calculated. Similarly, has given that what is the guided wavelength for this rectangular waveguide 2? The lambda g2 is equals to, this is lambda 2 divided by cos theta. So this will be, okay, cos theta. So this will be is equals to lambda 2 divided by cos theta is how much? Root over, for the second waveguide, fc2 divided by f2 whole square. Okay, f2 is given, fc2 we have to find. We have to find fc2. So this is the thing we have to find. Okay, we have to find the cutoff frequency of the waveguide R2. What he has given? These two are equal. Lambda g1 and lambda g2 are equal. It is given. Lambda g1 is equals to lambda g2. Okay. It is, what is lambda g1? Lambda g1 is equals to lambda 1 divided by root over fc1 minus f whole square. So already we found it is 15 centimeter divided by root over 1 minus, what is fc1? fc1 is 1 divided by f1 is how much? f1 is 2 whole square. Both are in gigahertz. Both are in gigahertz. So this is equal to, what is lambda g2? Lambda g2 means lambda 2 divided by this one. So what is lambda 2? Already we found. We found lambda 2 as 7.5 divided by root over 1 minus fc2 is how much? fc2 we have to find. We have to find fc2 divided by f2. How much? It is 4 whole square. So from this, if you simplify this, here it is 2 divided by, it is root 3 by 4 is equals to, it is 2, okay, divided by, so this will be equals to 1 divided by 1 minus fc2 divided by 4 whole square. So if you square this, how much you will get? If we simplify this and simplify and square it, then you will get, it will be, so you simplify this, here 2 divided by, if you square this, how much you will get? Here it will be 4, square it 4, So 4 into 4 divided by 3. 16 divided by 3 is equals to, I am inverting this also. So 1 minus FC2 divided by F2 whole square. So from this, FC2 divided by F2 whole square is equals to 1 minus 16 divided by 3. Right? Not 16. Okay, you have to invert this, right? So this will be 3 divided by 16. It is 3 divided by 16. Okay. So now here it will be, it is equals to 13 divided by 16. Now what is FC2? FC2 we have to find. So FC2 whole square divided by F2 square is how much? F2 square is 16 is equals to 13 divided by 16. So this implies FC2 is equals to root 13 gigahertz. Okay. So this is the answer. So what is the clue here? The clue here is the guide wavelength. So you should know what is the guide wavelength. Guide wavelength is equals to the wavelength divided by cos theta. The cos theta is root over 1 minus Fc divided by F whole square. Okay, two rectangular waveguides and both are air field given. Air field given means there is no epsilon r. Epsilon r is equals to how much? 1 for the both waveguides. Okay, there is another air field rectangular waveguide. Okay, both are air field rectangular waveguides. So this is the answer, right? So the questions are easy and mostly they are asking in the gate pattern only. Suppose if you can answer the gate questions of the previous questions, mostly you can answer the ISRO gate question paper. Okay. So this is the next question. So this is also asked in the 2017 ISRO exam. Okay. So read this question. An EM wave propagates through a lossless insulator with a velocity of 1.5 into 10 power 10 centimeters per second. We'll stop. Calculate the electric and magnetic properties of the insulator if its intrinsic impedance is 90 pi ohms. Okay. So here the electric insulators, that means what we have to find? We have to find the electric and magnetic properties. So here in the options he has given, option A, it is epsilon r and mu r values. Epsilon r and mu r values. Option B, epsilon r, mu r values. So here the options given here are 2.66, 1.5, 2.66, it is 1.5. Next one is 1.5, 2.66, 1.5, it is mu r is 2.66. Here epsilon r is equals to 1.2. Mu r to 1.2, mu r is 2, option D. Epsilon r is equals to 2, epsilon r is equals to 2, mu r is equals to 1.2, mu r is equals to 1.2. So we have to find these values. Electrical and magnetic properties means we have to find the dielectric constant and the permeability, right? So what he has given, an EM wave propagates through a lossless insulator. Okay, lossless medium. It is propagating in a lossless medium with a velocity. So what velocity? It is the phase velocity is given. Phase velocity of the EM wave is given. Now we have to find the epsilon r and mu r values and also calculate the electric and magnetic properties of the insulator if its intrinsic impedance of that medium is 90 pi ohms. Okay. So write the data. So it is a lossless medium. It is very, very important. It is a lossless medium, right? But it is a, what is the phase velocity? The phase velocity is given. It is equals to how much? It is 1.5 into 10 power 8 centimeters per second. Okay. So write this one as 1.5 into 10 power 8 meters per second. You can write like this, right? But it is given that it is a lossless insulator. So lossless insulator means there are two kinds of lossless mediums. So one is free space. One is free space and another one is lossless dielectric. So out of these two, which one is the medium? Out of these two, which one is the medium? So it is the medium of propagation because the phase velocity is not equals to 3 into 10 power 8 meters per second. So that's why, what is the phase velocity in a lossless medium? The phase velocity in the lossless medium, Vp is equals to, in a lossless medium, what Vp is equals to 1 divided by root mu epsilon, right? So you can write this one as, observe this, you can write this one as 1 divided by root over, it is mu naught mu r epsilon naught epsilon r. Okay, but it is not a perfect dielectric. Observe this, it is not a perfect dielectric, it is not a dielectric, it is given that insulator, you don't misunderstand with the dielectric. So this insulator will be having some kind of magnetic properties. Okay, so observe this, it is not a free space, but it is a lossless insulator. Okay, in this question it is given that it is an insulator. Suppose if it is a lossless dielectric, then mu r will be 1, but in the options it did not specify that 1 is not there anywhere. Okay, so that's why you cannot go for mu r is equals to 1, because it is not given that it is a non-magnetic material, right? So this is the thing, so this is the Vp. So from this, how can we write? So C divided by, C means what? Root 1 divided by root over mu naught epsilon naught is C divided by root over mu r epsilon r, So this is the thing you have to identify. So from this, so 1.5 into 10 power 8 is equals to 3 into 10 power 8 divided by root over mu r epsilon r, So from this, how can you get? So from this it is 2, right? It is 2. So from this you can get mu r epsilon r is equals to 4. This is one relation, right? Now one more important thing is given, intrinsic impedance. What is the intrinsic impedance? Intrinsic impedance is equals to root over mu divided by epsilon. So you can write it is mu r mu naught divided by epsilon r epsilon naught. So from this we know root over mu naught divided by epsilon naught, it is 120 pi into root over mu r divided by epsilon r. But it is how much it is given? It is given that 90 pi ohms. Suppose if we simplify this, it is 4, it is 3. Okay, by 30 you can divide this. So from this you can get how much it is. This is root over mu r divided by epsilon r is equals to 3 divided by 4. So 3 divided by 4. So from this, how can we write? If you multiply these two, then you will get how much? Now take these two values here. Okay, mu r epsilon r is there, under root this one. So if you take root for this, how much you will get? If you take a root for this, you will get 2 here. So from this, if you multiply this one, root mu r epsilon r into root mu naught mu r epsilon r is equals to how much? It is 4. It is 2 into 3 by 4, right? So from this epsilon r gets cancelled. It is by 2 will get cancelled. So from this, so what is the mu r value? Here from this mu r you will get mu r is equals to, here mu r is equals to 1.5. So if you put this value here, so from this what is epsilon r? So this implies epsilon r is equals to 4 divided by 1.5, right? 4 divided by 1.5. So 4 divided by 1.5 is how much? It is 2.66. So here 2.66. Epsilon r value 2.66 and mu r is equals to 1.5. So it is a common practice that every time we are taking mu r is equals to 1, but he did not specify that it is it is a non-magnetic material. If it is a non-magnetic material, you can take mu r is equals to 1, but it is not there here. He has given that it is a lossless insulator, but it is a lossless medium. Okay, lossless medium. So lossless medium means what? It is a free space and lossless insulator is given. So that's why you cannot consider this one as lossless dielectric. Okay, so this is an insulator. So this is saying that this insulator is having some mu r value. Okay, mu r value. So like this. So you should know what is Vp. The phase velocity for any medium can be represented as root over mu epsilon. So this is the point you have to understand, right? Now come to this question. So what is the option here? The option here is mu r is equals to 1.5, epsilon r is equals to 2.66. So it is answer B. Mu r is equals to answer, epsilon r is equals to, yeah, this one, option A is the answer. Option A is the answer, right? Now come to the next question. It is also asked in 2017 examination ISRO. Okay, it is also asked in the 2017 examination ISRO. Write this. See, observe this. A square wave. Observe this. A square waveguide. A square waveguide means it is a shape of rectangular waveguide only. Okay. A square waveguide carries TE11 mode whose axial H field, magnetic field, is given by, it is given. Okay, Hz is equals to H naught cos pi x divided by root 8 cos pi y divided by root 8 Az ampere per meter, where the guide dimensions are in centimeters. Okay, the guide dimensions are in centimeters, it is given. Okay, now what is the cutoff frequency of the mode? So we have to find the cutoff frequency of this mode. Which mode? TE11 mode. It is definitely, it is TE11 mode because the magnetic field in the Hz direction, Z direction, the magnetic field in the propagation direction, right? So if you observe this, see, now compare that given axial field with this one. So Hz is equals to, this is H naught into cos m pi by a into x. Okay, cos of m pi by n pi by b, n pi by b into y as ampere per meter, right? Now compare these two. If you compare these two, what you will get? Actually, what we have to find? We have to find the cutoff frequency. To find the cutoff frequency, what is the cutoff frequency expression? Fc is equals to root over m by a whole square plus n by b whole square into c by 2. I am writing the c by 2 here. Fc is equals to c by 2 into root over m by a whole square plus n by b whole square. Right? C is called as the velocity. Okay, light velocity 3 into 10 power 8. It did not mention anything, right? So we have to consider C as 3 into 10 power 8 meters per second. But what we have to find? We have to find, so it is in which mode? It is TE11 mode. That means m is equals to 1 and n is equals to 1. But what we have to find? We have to find A and B are not there here. A and B are not there here. So we have to find A and B values. We know m and n values and we know c values also. To find the cutoff frequency, we should know the A and B values. So if you compare these two equations, now, so m pi by A, what is m value? M value is 1, n value is 1. So 1 into pi by A is equals to, it is pi divided by root 8. So this implies A is equals to root 8. So similarly, 1 into pi by B is equals to pi divided by root 8. So this implies what is B? B is equals to root 8. A is equals to root 8. B is equals to root 8. So what is the meaning of this? So it is a rectangular waveguide only, but it is in a square shape. Right? A is equals to, here A is equals to root 8 and B is equals to root 8. It is a square shape. Right? It is a square waveguide. Right? Now what we have to find? We have to find the cutoff frequency. FC is equals to C by 2. 3 into 10 power 8 divided by 2 root over m by a whole square plus n by b whole square. A and b are equal. So you can write 2 into 1 divided by a whole square. A is how much? A is how much? Root 8 whole square. So from this you can get, so this is 2, this is 1 divided by 8. So you can get, this is 3 into 10 power 8 divided by 2, and it is 1 divided by 4. 1 divided by 4 means 1 divided by 2. All are in centimeters it is given. Okay. So from this, all are in centimeters means, how can we write? This is, all are in centimeters, so this will be 100. 10 power 2. Right? This is in centimeter. So that is centimeter square is centimeter only under root. Okay. So here you will get, it is 3 by 4 means 7.5. 3 by 4 means 0.75. Okay. It is 0.75 into 10 power 8 into 10 power 2. So this will be, how much you will get? So finally you will get 0.75 into 10 power 10. So finally you will get 7.5 gigahertz. Okay. The answer is 7.5 gigahertz. Right. So this is the final answer. So there is no difficulty in this question. Just you have to relate what you know. Okay. So there is no difficulty. Just you have to, sir, whenever these kind of questions, see, this question is also copied from the GATE examination. Okay. This one also, this one also. So every question is copied from the GATE examination only. Just either they are copying the question or just they are changing the numericals. Okay. So you have to focus on the GATE examination paper. So mostly they are similar to the GATE examination only. So it is very easy for you to solve. Okay. Thank you.